Okay, so we're given this rational function. Notice that it's in standard form, it's not factored, and we have a whole bunch of questions to answer about it. And the first part says, hey, I need you to simplify this to lowest terms. All right, so what we need to do is to factor everything to make sure that we have it simplified. So let's start with the numerator. We have 2x squared minus 11x minus 6. I'm going to use the bottoms up method. That means we're looking for the product of a times c, which is 2 times negative 6, which gets us negative 12. And we need a sum of b, which is negative 11. This means that the two numbers we need are negative 12 and 1, because negative 12 times 1 gets us negative 12. And when we add the two together, we get the negative 11 for which we were looking. That means that we can start writing our factors. We're going to have x minus 12 because we have the negative, and x plus 1 since the 1 is positive. Since we're using the bottoms up method, you have to have a bottom, which means that we need to divide both of our constant terms by 2, which is a. Reduce our fractions. 12 divided by 2 gets me 6. When we try to reduce 1/2 in our calculator, it spits back 1/2. But remember, whenever you still have a denominator hanging out in your constant term and your factor, so fancy way of saying, hey, you still got a fraction, bring that thing on up. So the x minus 6 is going to stay the same. And that 2 comes up to be 2x plus 1. So our numerator factor is x minus 6 times 2x plus 1. Let's see what we get for our denominator. Our denominator in this case was x squared minus x minus 56. Oh, plus x minus 56. And here we're looking for a product of 1 times negative 56, which is negative 56. And we're looking for a sum of 1. The two numbers we need are 8 and negative 7, because 8 times negative 7 gets us negative 56, and 8 plus negative 7 does get us the one that we needed. So we're going to have x plus 8 times x minus 7. We could divide by a still because of the bottoms up method. But dividing by 1, which was our a in this case, doesn't really change anything for us. We still get x plus 8 times x minus 7. So if we go ahead and write that in, x plus 8 times x minus 7, we see that this doesn't simplify at all. This is our lowest terms. So we can't cancel anything out. Nothing repeats top and bottom. We're going to take that denominator. We're going to set it equal to 0. Okay, since nothing's simplified, we don't have to worry about missing any pieces of our domain. We're going to take the entire denominator, set it equal to 0, and you should be finding the domain before you simplify anyway, because if something cancels out, it still can't be included in the domain. So we would get x plus 8 equal to 0, which tells us that x cannot be negative 8. And x minus 7 equal to 0 tells us that x cannot be 7. So when we're writing the domain, if you need a visual, remember negative infinities on the left, positive infinities on the right. We cannot be negative 8 and we cannot be 7. So go ahead and get rid of both of those. Our domain, we're going to start with negative infinity to negative 8. Then we need negative 8 to 7. We're using the union in between, the jump rope to jump over the cracks. And then we have 7 to infinity. Remember that all of your brackets and parentheses in your interval notation need to be parentheses because we cannot actually be these numbers. We have to exclude them. Okay. Remember that the values that we find from the domain are our restricted values. And all of our restricted values either become wholes or vertical asymptotes because nothing canceled. These are both left in the denominator, setting each one equal to 0. We find out that we have vertical asymptotes, VAs, of x equal to negative 8 and x equal to 7. So in this case, we have two vertical asymptotes. Now that we've found our vertical asymptotes, looking for the wholes, since we had nothing cancel, that means that we have no wholes. Remember, to have a whole, you need to have a factor that canceled out. We need to find any horizontal or slant or oblique asymptotes. Remember, slant and oblique are the same. They're the y is equal to mx plus b form. Our horizontal asymptote is y equal to some number without the x included. And this is all dependent upon the degree of the numerator and degree of the denominator. If we look at the degree of the numerator, we had x minus 6 times 2x plus 1 in factored form. Or, scrolling up, you can see that we had a x squared as the highest term in the standard form, and the x squared in the denominator, which means that the degree of the numerator is 2, but the degree of the denominator is also 2. And because they are equal, that's when you have a horizontal asymptote, an HA, of y equal to the ratio or fraction of your coefficients. So if we're looking at our unfactored form, we had a 2x squared in the numerator, so 2, and a x squared or a 1x squared in the denominator, so coefficient of 1, which means our horizontal asymptote is y equal to 2. We don't leave it as 2 over 1, simplify it down. And you have to have the y equals, otherwise you do not have the equation of the asymptote. Y-intercept. Remember, we find the y-intercept by plugging in x equal to 0. So depending on which form you want to use, you can use the factored form or the original because nothing simplified. If something had simplified, you would need to use the simplified form. Okay, so I'm going to go ahead and use the factored form, which we said was x minus 6 times 2x plus 1, which is going to get me 0 minus 6 times 2 times 0 plus 1, plugging in my zeros. And in the denominator, I had an x plus 8, so I'm going to have 0 plus 8. And I also had a 0 or x minus 7, which gives me 0 minus 7. Simplifying everything down, up top, I'm going to get negative 6 times 1. Down below, we're going to have 8 times negative 7. We get negative 6 all over negative 56. And this reduces to a positive 3 all over 28. And our ordered pair is 0, comma, 3 over 28. Setting the top equal to 0. Again, nothing canceled, but we already have factored form. So we're going to have x minus 6 times 2x plus 1 equal to 0. X minus 6 equal to 0 gets me x equal to 6. 2x plus 1 equal to 0 gets me x equal to negative 1/2, which means I have the ordered pairs of 6 comma 0 and negative 1/2 comma 0, because we plug 0 in for y. Just because we found 2 x-intercepts doesn't mean that we only found one ordered pair. Don't try to push them together. Okay, if you told me 6 comma negative 1/2, no, we have a y value of 0.